All right, we are asked to find the 6 trig functions of theta in standard position if the terminal side passes through 8, negative 15. So first thing we're going to do is plot that ordered pair, 8, negative 15. I actually don't think that it fits on this graph, so we'll do the best we can. If you go over 8, that gets you to here. Then you have to go down 15, but our graph only goes to 10. So we will just kind of continue the graph a little bit. Over 8 down 10, 11, 12, 13, 14, 15. So that's the point 8, negative 15. So what's happening is we have an angle that is going through that point. The terminal side is going through that point. So it looks something like that. And we have to evaluate the 6 trig functions. So what we do is we create a triangle. We did a little bit of this in the last lesson. When you make your triangles, you're always going to connect this to the x-axis. So we're going to connect straight up to the x-axis. Our angle that we are evaluating is at the origin, angle theta. So technically, this angle, in standard position, could be going around this way. And so we are looking at the reference angle, or it could be a negative angle with that same reference angle. So it kind of ties in with the reference angles because the angle that we are evaluating is right here at the origin and is considered a reference angle. So when you go over 8, that makes that side length 8. Another new thing for this lesson is when you go down 15, this side length is going to be a negative value. So we want to make sure that that negative is there. And then now we have to find our third side, so we'll do Pythagorean Theorem. A squared plus b squared equals c squared. So 8 squared plus negative 15 squared equals c squared. If you're using your calculator for this negative 15 squared, make sure that that is in parentheses. We have 64 plus 225 equals c squared. When you add those together, you get 289. Square root both sides, and c is equal to 17. So that worked out kind of nice. So I'm going to go ahead and put that 17 right there. All right, the other thing we would like to do is label our 3 sides in terms of theta. Across from theta, this negative 15 is the opposite side. So when we need to use the opposite side in our trig function, SOHCAHTOA, there it is. 17, I always do that one next, is the hypotenuse. There's our 90-degree angle. It's always across from the 90 degrees or the longest side of our triangle. And then this 8 is the adjacent side. All right, so we did all the legwork. We are ready to evaluate our 6 trig functions. We start with sine. Sine is equal to opposite over hypotenuse. So opposite is negative 15. Hypotenuse is 17. That cannot be reduced, so that's our answer. Because of this negative value right here, this negative 15, you're going to see that some of our sine, cosine, tangent values are negative. That's okay. All right, cosine of theta, should have thrown theta right there, is adjacent over hypotenuse, so 8 over 17. That one's positive because we did not end up using that negative 15 side length. Tangent of theta is opposite over adjacent, so negative 15 over 8. All right, then the other 3 we want. What's the reciprocal of sine? That is cosecant of theta. And all I have to do is flip these around, 17 over negative 15, or just negative 15 seventeenths. Cosine and secant are reciprocals of each other. So I'm just going to go ahead and take that 8 over 17 and flip it to 17 over 8. That is an 8, hard to tell. There we go. And then which one goes with tangent? That is cotangent of theta. Negative 15 over 8, flip that to an 8 over negative 15, or a negative 8 fifteenths. And those are our 6 trig functions.